All right, everyone, let's begin. Hello and welcome to our biannual Better Buildings Alliance Plug and Process Load technical team call. This is Rose Langner, and for those of you who don't know me, I am the technical team lead for the Better Buildings Alliance Plug and Process Load team. I'm an architectural engineer and a building scientist in the Commercial Buildings Research Group here at the National Renewable Energy Laboratory, which is located in Golden, Colorado. Next slide. For those of you who are new to this call, this is our Better Buildings call that is focused on solutions to understand and control the energy consumption of all plug-in equipment and miscellaneous electric loads in a building. And those equipment and loads are basically everything that is not related to heating, cooling, ventilation, water heating, or any other major building function. It's everything else that consumes energy in a building, and it's a lot of little things that can add up to a lot. Next slide. As we can see in this slide, which is data from our EIA Annual Energy Outlook 2015, plug loads typically consume over 30% of whole building energy use. And this percentage is expected to grow over the next 15 years due to the fact that other building systems, such as lighting, HVAC, and building envelope, are becoming more and more efficient. And we're seeing a lot more plug-in equipment becoming more available on our market. So the right side of this graph shows the commercial sector values for 2016 in the third column, and then projections for 2030. So it's expected to grow to about 43% of the whole building energy consumption. On the left side of this chart, we see the residential distribution here, where plug loads and miscellaneous electric loads consume roughly 30% now and are expected to grow to 34%. Next slide. So this is significant, and the good news is that when we introduce plug load controls, we typically see up to 30%, and I've actually seen some savings up to 40% for individual pieces of plug-in equipment. And this often translates to about 7 to 10% energy savings for the entire building. So plug loads are significant and should not be overlooked. And in fact, they're more and more on the radar of facility managers these days, efficiency programs, utilities in particular, et cetera. So it's become a very hot topic and kind of a next frontier of building loads that we need to better understand and learn how to control. Next slide. So for today's call, I will start with a few updates from the Better Buildings Alliance Plug Load team. Then we'll go on to our technical presentations, leaving some room at the end for open discussion, Q&A, and any additional partner updates if anybody has them. So for this call, everyone will be muted, but please type in questions into the question box on the GoToWebinar control panel when they arise, and we'll keep track of those and respond to them either at the end of the presentations or as we move forward. We're also going to send these slides out after the call. It'll probably take us a week to post them to the Better Buildings Solutions Center, but once we do that, we will send a link to all the participants and people who registered for this call afterwards. So our technical presentations today will be given by Michael Klopfer and Joy Pixley from CalPlug. And CalPlug is short for the California Plug Load Research Center, which is part of the University of California, Irvine's Institute for Telecommunications and Information Technology, which is also known as CalIT2. CalPlug is conducting a bunch of research in the plug load space, and a lot of it is funded by the California Energy Commission, and we're very excited to have Michael and Joy on this call so that we can learn more about their work. Next slide. So starting with some tech team updates here, I'd like to introduce Dr. Kim Trenbath. Kim is an industrial engineer in the Commercial Buildings Research Group at NREL, She has been working closely with me to help lead the Better Buildings Alliance plug load team and will be NREL's main point of contact while I'm on maternity leave starting here in May. Kim's projects at NREL include this work through the Better Buildings Alliance, automated fault detection and diagnostics, and zero energy K-12 schools. Prior to these projects, she was the group's business manager and previously worked as an analyst in global power strategic sourcing, risk management, and wind energy business development. Her prior research involved in-cabin air quality, science understanding, and break-in training. So I'm very happy to have Kim joining this team, and you guys will all be in very good hands while I am on leave. Next slide. Additionally, I'd like to point out that we've had continued support from Marta Shantz and Sormay Konjkov from Waypoint Energy. They have been a tremendous asset to the plug load team for many years now. I know many of you have worked directly with them and will continue to do so as the plug load team moves forward. So between the four of us, that's the leadership for the plug load team here. Next slide. So some team updates here. I wanted to go through webinars and conferences. A past webinar that was recently gave a month ago, February 8th, 2018, GSA Proving Ground did a webinar on advanced power strips for plug load controls, which I was a guest speaker on. You can download this webinar from the link provided there, or if you Google the GPG Outbrief webinars, you'll see a link to the recording and slides for that webinar. Next slide. There are a couple conferences I wanted to point out. This year, our annual Better Buildings Summit will be held with the Department of Energy's Energy Exchange, which is typically focused on federal facility and energy management. The joining of these two conferences will provide greater access to technical discussions and trainings, while also providing great panel sessions, keynote speakers, and of course, networking opportunities. So save the date. The summit will be held August 21st to 23rd in Cleveland, Ohio, and we hope you all can join us out there. It's a great conference to attend. Next slide. Additionally, the plug load team will be represented at ACEEE Summer Study, which is going to be held August 12th through 17th in Pacific Grove, California. We are pleased to announce that we had 2 abstracts accepted around plug loads. One will be for a paper under Panel 12, Smart Buildings, Smart Grid, and the Internet of Things. And this paper is focused on how to navigate communication protocols and cybersecurity implications of wireless meter and control technologies for plug loads. I will be the lead author on that one and working closely with my colleague Dane Christensen here over at NREL, who is in our residential group. The second abstract is for a poster display presentation, and this is really focused on how do we use metered plug load data to sense occupancy and implement controls. And this work will be based off of a project that NREL is conducting through the Wells Fargo Innovation Incubator Program with a smart outlet company called IBIS Networks. We're basically using their smart outlets to meter plug loads in an office space and understand usage patterns of those plug loads so that we can determine occupancy and ultimately recommend control schedules for individual pieces of equipment. So that study will have preliminary results by the time of the ACEEE Summer Study, and we're excited to present those during the poster display presentations there. So hope you guys can join that conference as well. Okay, next slide. And before we launch into our technical presentations, one more update. This year, the plug load team is focused on a landscaping study to figure out how to better integrate plug load controls into building automation system and energy management information system platforms. So basically, this is a literature review to understand the status of the market and where the Department of Energy can really support integrating these controls into BAS and EMIS platforms. And our literature review will focus on, of course, connected devices, wireless meter and controls for plug loads, what the data flows are for the information to get to the BAS and EMIS platforms, how we can integrate plug loads into other building systems, et cetera. We'll look at communication protocols, interoperability with other systems, cybersecurity issues, et cetera. So we're excited to embark on that project, and we will be addressing initial findings of this at the upcoming Department of Energy's Building Technologies Office peer review, which will be in DC in the beginning of May as well. Next slide. So those are the updates from the tech team, and I want to introduce our speakers one more time. Again, our speakers are from CalPlug, which is short for the California Plug Load Research Center, which is part of the University of California Irvine's Institute for Telecommunications and Information Technology. That's also called CalIT2. And CalIT2 is a two-campus multidisciplinary research institute. It's one of 4 UC Gray Davis Institutes for Science and Innovation. And CalIT2 leverages academic expertise with industry experience to conduct cross-cutting or cutting-edge research in diverse fields. Their goal is to develop innovative information, technology-based products and services to benefit society and ignite economic development in the region and state. CalIT2 at UC Irvine hosts several centers, including CalPlug. CalPlug was established to improve energy efficiency in the use and design of applications and consumer electronic devices. They focus on energy efficiency solutions, efficiency evaluations of consumer electronics, standards development, education and public outreach, and user behavior studies. CalPlug addresses challenges in plug load efficiency for both residential and commercial buildings by collaborating closely with utilities, manufacturers, advocacy groups, research institutions, and energy policy makers. The campus of UC Irvine has asserted a firm commitment to energy efficiency and natural resource protection as well. So Michael Klopfer, the technical director at CalPlug, has a doctorate in biomedical engineering from UC Irvine. And prior to joining CalPlug 2 years ago, Michael consulted for system design in a number of fields, including consumer electronic development, Internet of Things solution development, and medical device design and development. And Joy Pixley has a doctorate in sociology from Cornell and has worked in the field of survey and experimental research methods for over 20 years. She is a project manager for social sciences at CalPlug, focusing on user behavior and energy efficiency. So with that, let's go to the next slide. And Michael, I'll hand it over to you.
Rose, thank you so much for the great introduction. We're very excited to be talking with very like-minded individuals on a topic that we hold so dear to ourselves. You covered many of the main bases about what we do and what our focus is as an organization, but I'd like to go into a little bit more detail about what our mission is, what we're directed to, and then lead off onto a particular project that Joy has been working on, which has some fantastic results that we'd like to present towards the end of this discussion. Please advance. So as Rose, go ahead and click it a couple times just so they all come up. Perfect. As Rose mentioned, we're a multidisciplinary center that's based at UCI, and we have a focus on a number of points of commercial and residential miscellaneous loads and subgroup of plug loads. From this, we have multifaceted considerations that we're looking at. And what this means is to deal with a number of these problems, they have to be addressed between multiple groups and at multiple levels. This includes the technology level, the policy level, the user interface level, and market and adoption. So all these pieces have to come together. All these moving pieces have to be aligned to move practical solutions forward. And this is what we do on our side. We host workshops on a variety of plug load topics. Last year, we hosted a European conference on domestic lighting and appliances called EDOL. And in this, we were hoping to foster connection between international work on this. And even though this was a European conference, there was representation from other locations outside of the United States. At the same time, we also host workshops on special topics and our own topics that we put together and bring in individuals from these different groups here, from manufacturers, consumers, retailers, and utilities to talk about particular topics and draw out some specific technical and market aspects of this to go into deep discussion on. In addition, we work with utilities to develop programs and investigate products and solutions. We've done a number of projects on Tier 2 advanced power strips on both residential and commercial side to understand how these devices can be used to save energy. This is one direction, but we've done a number of other ones that we can mention later. We've also worked with manufacturers on voluntary agreements and also with policy makers to put together new codes and standards. In addition to this, we work on a number of in-house advanced energy savings control systems, and we do demonstrations of these systems in addition to looking at what manufacturers have produced and validating the operation of these from a third party. As another part of our work, we also focus on education. So in addition to coming up with solutions, we work with trying to educate the community at large and also individuals within the university on specific energy saving topics. Please advance. Go ahead and advance to the, thank you so much. So to get into a little bit more about the education side, we have educational workshops that we host here for K through 12 students. One particular activity that I like to share is our 1 kilowatt-hour challenge, where students will play games that involve using energy that relates to specific household tasks. And from this, they understand what energy is used for these tasks, and accordingly, they offset their own energy with mechanical power. This is a way to show that a kilowatt hour saved is better than a kilowatt hour generated. So going and inspiring the next generation is one of the focuses that we have. In addition to this, we work with 24 undergraduate and graduate students hand in hand in our collaborative work. So they work with us on the policy side, they work with us on the technical design side, and the goal here is to develop the next generation of clean tech leaders who can work between technology and policy in an interdisciplinary fashion. Please go ahead and advance. Perfect. So the major issue with plug loads, as was previously addressed, is that the problem is a non-static problem. So once you've modeled what's there, the problem is always changing. You have changing devices. For example, on the residential side, you'll have more personal and more distributed devices. This is also carries over to commercial. There you have a little bit more control as far as what's going in the building, but there's many points of integration that need to be built out, that can be built out, and there's a lot of opportunity there. In addition, you have changing configurations for these setups. There's a number of opportunities and challenges on the commercial side as far as building integration and control. And then the Internet of Things, as far as how this relates to control, is another part that we look at. For example, a number of smart bulb solutions that claim to be producing net savings in many configurations will actually not save anything. They'll actually use more energy just because of the sleep states and how the management is working. So considering how this fits together in policy, for example, Title 24 has an exception. This is California Title 24 building code has an exception for controlled devices. So figuring how these fit into larger elements is one of the things that we look at. Go ahead and advance. So addressing a couple of these specific cases, the first is integrated and adaptive controls. How can this be drawn out and improved? And extending from this, user interfaces is another concern. This is going to be something that Joy is going to focus on in her discussion. Also, population demographic shifts are a consideration. On the residential side, medical devices in the home is a consideration, but on the commercial side, there's a number of distributed clinics that are out there, and how to integrate energy controls into the healthcare field is still an area that's being explored. Also, decarbonization and electrification. What California is working on right now with trying to remove natural gas resources from new builds and transfer this over to electrical sourced energy has a number of issues associated with how energy is sourced, whether it's a distributed load that's coming in, and accordingly how the demand is set around the loads. And how plug loads fit in this is something that we're currently investigating. Additionally, on top of that, the transportation side in California, we have a governor mandated target of 5 million electric vehicles on the road by 2030, and how this fits together and how demand can be managed with charging, either as a resource to provide sloshing of power back onto the grid when needed, or charging at points where power is in excess is something to consider, and how tying this together with plug loads is a direction that can be explored in the future. With all this being said, I'd like to go ahead and shift over to a specific topic that we've spent the last 2 years researching. This is related to the controls on computers for energy management, which is something that has been looked at on our side, and Joy has gone into a deep dive on this, and I'd like to turn this over to her to discuss this in a lot more detail.
So next slide.
Next slide.
Hi, great. So Mike gave a really good overview of what we do here at CalPlug, and now I'm going to dive in and talk more nitty-gritty on one particular project. Now, we've been working on the issue of computers more broadly and power management for about 5 years now. What we're working on right now is actually the third project we've done so far. So I want to give you a little background on the first two projects first. The first project was a survey of over 2,000 people where we asked them all about their home desktops, their office desktops, and their laptops. And one of the many things we asked them was whether or not their computers went to sleep. And the vast majority of them said, yes, my computer goes to sleep. We were a little bit less for office desktops. We had more people who were confused by that, but we thought that those initial results were very positive. Then we did a second study, and then we got less positive. In the second study, we actually went and monitored a subsample of just over 100 of those office desktops, and the results for those desktops are what you see here. So the first line is, what did these particular people report about their computer sleep settings? And we see that 78% of them said that their sleep settings were enabled. But when we looked at it, only 20% of them actually had their sleep settings enabled. So that's obviously a problem. Can you click, please? Click to the next one. There we go. So this identifies three different groups of people. On the one hand, we have the 20% of people who said that their sleep settings were enabled, and they were. So those are, we don't have to worry about them. Everything's fine with them. We have the 13% of people who know that their sleep settings are disabled and presumably want them to be, and we're going to put them off for a different project. It's that middle 2/3 that we want to deal with now. And these are people who either think that their sleep settings are enabled or aren't sure, but they're not. So those are the low-hanging fruit, we hope, that we want to find a solution for. And the solution that we were proposing was to design and test a new user interface, a new software app, to get people to access sleep settings in a slightly different way, and to give them feedback that was going to encourage them to use these power management options that are already available. So there's no really serious technological change that has to happen. We just want to change the behavior so that what's there is actually being used efficiently. This is publicly funded by the California Energy Commission through the EPIC program. We take that very seriously. Okay, next slide, please. So the name of the project and the name of the app itself is the Power Management User Interface, or PMUI, which is very awkward, so we just call it PMUI. And the first stage there is, it's a terrible brand, but we're not into branding, we're into science. So the first stage is to design the interface, and we wanted to build on the huge amount of research that's already out there on psychology and behavior change and human-computer interaction, and particularly on the kinds of intervention programs that have already been done in residential areas and residential applications, where you give them feedback on their household energy use and see what makes the difference for actually reducing their energy use at home. And so one of the things, what worked best for that, how can we utilize that? And the first step for that is to keep it simple. We're only managing computer sleep and display sleep. We're not messing with things like hybrid sleep or hibernation or anything complicated like that. The whole idea is that it should be very easy to access, easy to use, easy to understand, and very motivating. So we found, for instance, that people were pretty confused by some of the aspects of the standard, say, Windows or Mac settings, that they would look at their settings and say that it said that it was balanced, but then you look at the next page, and even though it's balanced, somebody has actually set the settings to never. So that seemed to confuse people a lot. So in general, what we're trying to do here is providing people with actionable information. What is the problem and what can you do about it? So I want to be clear here about what our focus is. We are not trying to develop some product that we're going to sell and make a profit on. Nobody's going to buy this. This is a scientific inquiry into whether we can actually change people's behavior enough to make a serious dent in the energy waste. How well does this kind of feedback work for computers, where we, again, already have this sleep setting available? And maybe, in the future, how can we be able to apply that to other sorts of devices that you have in the home that, again, have these kinds of sleep settings, and the user behavior is important. So in order to, so basically, like, we're in this for the energy savings. We want to save as much energy as possible. And so to facilitate that, we made two choices. One of them is that we built the entire thing using only free software and open source software. That will enable us to have a much freer distribution, much more opportunities to be able to develop this in different contexts and get it out to more people. And we also designed it to be a standalone program. So a lot of these other feedback programs require that the user be part of some sort of organization where you're going to compare their usage to their neighbors or to their coworkers or something like that, or they have to be hooked up to, say, your utility bills. So you're comparing your use to how much energy or how much money you're saving compared to last month. And these are great, don't get me wrong, but it does limit you being able to use these comparisons does limit how you can distribute it. So we designed this as a standalone where you can just download it straight from the internet and use it on your own computer for your own use to save energy. And so the overall idea is that this will enable us to use this in a much wider range of contexts, from low-income households to small businesses to large businesses. Anybody who wants to use it will be able to save energy. Next slide, please. So I'm going to show you a little bit about the interface itself, and then I'll talk about the study that we're doing where we're testing it. So this is the sleep settings page, and I want to point out a couple things about it. First off, like I said, it only has computer sleep and display sleep, and it has a slider for both of those that you'll notice we're using a little bit of psychology here, because the middle of the slider bar is 30 minutes for computer and 10 minutes for display, and that's our target level, really. We'd like it to be better, but that's our target. And we're using psychology because we know from past research that people don't like to be worse than average. So if we sort of communicate to them that that's the average, they're more likely to be at that point or lower. The second thing I want to point out is look at that little bottom box to temporarily disable. We were wondering if maybe some of the reasons why people's computers were disabled, the sleep settings were disabled, is because they turned them off for one particular event. Maybe they wanted to download something, or for some reason they wanted, to make sure that their computer didn't go to sleep. And then there's nothing that ever reminds them to turn it back on again. So with this, you can temporarily disable it. You click the little box. You can say for 1 hour or 8 hours or 3 days or whatever you want, and it'll show a sign that says it will come back on at a certain time. I also then, if you look up the how can I reduce my computer idle time, throughout the program, we're trying to stay very much on message that idle time is the bad thing. Idle time is what you are trying to reduce. So there's a whole lot of pop-up buttons and things that you won't be able to see on this slide that keep reinforcing that message and bringing you back to this page and suggesting that you enable your sleep settings and turn them down. If you look at the menu bar on the left side, you'll see that in addition to the sleep settings page, there are 3 different reports. So the idea there, again, we know from past research that different people respond to different kinds of reports, different kinds of graphic interfaces. And so we wanted to do a number of different ways of presenting this data, of giving them feedback, to have a higher chance that any one person is going to be engaged by one of them. So next slide, please. So this is the main page. This is the usage report page. And if you look at the pie chart on the left, this is your computer states. We've simplified the states that your computer can be down to 4. It's either off, it's in sleep mode, it's on but it's actively being used, or it's on but it's idle. And of course, again, we're using psychology because that red idle, we want to make that red as small as possible. We're comparing that to an energy saver target profile. I said earlier, we can't compare you to real people, but we can compare you to an ideal. So this is a chart, or the pie chart shows what the ideal level of idle would be given the same amount of active time that you have. And that little smiley face you see, that smiley face changes into a really big smiley face all the way down into a very, very sad face, depending on how your idle time compares to the energy saver target. And you might think it looks a little corny, but I'll tell you from the field test, people really do not like to see those sad faces, and they really want to see the smiley faces. So another thing to look at is at that top bar, you can see that you can look at this in terms of weeks or days or months, and you can scroll back and forth to previous weeks or days or months to see how your performance has changed over time. And again, people really seem to like that. At the very bottom part, again, we can't compare you to other people, so we were a little bit limited in what kinds of other motivations we could bring up. So we're bringing up pro-environmental messages, which we know some people will respond very positively to. So we're bringing up the idea that if you save energy by reducing your idle time, you'll reduce pollution. It'll be similar to having trees planted, and it will get cars off the road. And for those of us who are living near Los Angeles, cars off the road is a very positive image. Okay, going on to, hold on, did I get everything? Yes, next slide, please. This is the second kind. Here, this is looking only at idle time, and we're comparing your idle time for the day of the week this week to the day of the week the previous week. And again, you have smiley faces or frowny faces, depending on how much better you're doing this time. And again, you can scroll back and forth to see how well you're doing. So this might be for the person who is doing perfectly well during the week, but is leaving it on and finding out that diagnosing the problem is over the weekend. Okay, next slide, please. And this is one that a lot of people seem to really like. The top bar there is the computer states over time. So this is showing, in this particular example, for instance, that it was off for a long time, and then it was idle for a little time, active for a little time, idle. You can see when exactly your computer is going to sleep. You can see when it's idle. You can see when the problem cases are. And you can compare it directly to that bottom graph, which is what your computer's sleep settings were. Now, I'm now realizing as I'm looking at this, this is not the greatest example because the sleep settings, this is actually from my computer. So the sleep settings are set at 20 minutes the whole time. But imagine if you had your sleep settings set at never or an hour, and then you changed it down to 20, you would be able to see the effect that had on the amount of time that your computer was spending on idle and any given time. And again, you can look at this from different amounts of time, days, weeks, months, hours even, and then flip back and forth to be able to see. Another great feature of this is that you can diagnose problems with your computer where your computer was supposed to be going to sleep and it's not. And we've used that a lot too. Next slide, please. And then we have a series of frequently asked questions. These are both about the study, or both about the interface itself, and also about just in general, how do you save energy, and that's just kind of a standard thing. So that's the interface. Next slide. And now we'll talk about how we're testing it. So stage 2 is the field test. We're looking at desktops on UCI campus, and we're collecting a lot of different kinds of data. So on the one hand, we're collecting data on the actual energy consumption of these desktops in different states, the sleep settings themselves, the computer states, and by that I mean the off, on, sleep, and active, and the self-reports of various things. So in the first visit, the research visit 1, we do 2 things. We put PMUI on their computer in observation mode only, so it's only recording data and they can't see it. And we also install energy monitoring equipment. So we have a power strip, we plug in the computer and any monitors that are being controlled by that computer, and we have a plug meter that is giving us information about exactly how much energy it's using, and it's timestamped. So everybody then gets a 1-month baseline period of measurement. At the second visit, we asked them, that little tablet is supposed to be a questionnaire that they're filling out. We didn't want to ask them questions about their sleep settings in the first visit and bias their baseline, but we're going to ask them questions here at visit 2 about, their feelings about computers. Are they an expert or not? Do they change their sleep settings, et cetera? Then we also have, we break the people down into experimental group versus control group. And for the experimental subjects, we then activate the PMUI interface so they can now see it. And we say, hey, here's the next phase of the study. You can use it if you want to. And we're trying to make the control people just as similar as possible to the experimental people. So we open up their regular sleep settings and say, here, we're supposed to show you how to get to your regular sleep settings. You can use them if you want to. And then there's a 2-month period where we are recording, we're continuing to collect data on that and seeing whether or not that changes the behavior. In the third visit, we take away all of the hardware and the software and give them one more survey where we ask them questions about mostly how they liked the program. Okay, next slide. So I wanted to mention what the hypotheses are because the results will make a lot more sense. So the first thing is we want to make sure that people are changing their sleep settings in the second period instead of in the first period. We don't want to find out that people are just changing their settings randomly. So they're supposed to be changing their settings after the second visit. Most importantly, for those people whose sleep settings are disabled to begin with, what we would like to see is that the experimental people who have the PMUI interface are more likely to enable sleep than the control subjects who just looked at their regular settings. And similarly, second point, if they already have sleep enabled, we would like the experimental people to be more likely than the control people to improve their sleep settings. So reduce the delay time. If you had it set for an hour to go to sleep, now you set it for half an hour to go to sleep. But finally, we want to make sure that they're not doing bad changes too. And I think a lot of times with experiments, you don't look at that. You only look for the behavior that you want, and you forget to look for the behavior that you don't want. It's just that people are just randomly doing things. So we want to make sure that they're not randomly also making things worse. Next slide, please. So the data collection, the current status of this is that we have 419 subjects who have started. Most of them have finished the research visit 2. We have 292 who have finished the third research visit, and those are the people that we're going to be talking about these preliminary results. So I want to be clear that these are preliminary results when we also have an ACEEE paper that we're going to be presenting, and hopefully we'll have the rest of the results then. Next slide. So we'll start off by saying, what are we starting with in terms of whether sleep is enabled? So if you look at the first graph there, this is whether they said that they thought that their computers or their displays were going to sleep. And we see that 63% of them think that their computers are set to go to sleep, and 91% think that their displays are set to go to sleep. And like I said before, a lot of them say they don't know about their computer going to sleep. The second one, if you look just at the blue bars, this is telling you who is actually observed to have their sleep settings enabled. And so again, 63% thought their computers were going to sleep. Only 13% actually are going to sleep. It's a little bit different for the display. We have high engagement for the display. The display is simply not a problem. So we don't have to worry about that. We want to worry about the computer. Okay, next slide. So here are the big results. So the first two, we're looking at whether there's any change in that beginning baseline period versus in the experimental period, and we're seeing exactly what we would expect. There's a lot more change between the second visit and the third visit, particularly for the experimental people. So far, so good. That third set of bars, these are the people who had sleep disabled, and which ones of them then enabled sleep. And we see exactly what we want to see. 67% of the people who had PMUI installed, the experimental people, have enabled sleep as a result of being exposed to the PMUI program. But we also see that 18% of the control people have enabled sleep. So this is actually very positive. It turns out that just showing people that their sleep settings are disabled encourages 18% of them to activate it. And I get a lot of pushback from people about like, oh, if people wanted to enable their sleep settings, they could. I'm like, well, maybe they just don't know. So let's just show them to them. The fourth set of bars right there is for people who already had sleep enabled, did they reduce their delay time? And again, we see that a third of the experimental people do that. They go from, say, 30 minutes to 20 minutes or an hour to 30 minutes. So that's, again, a very positive result. And then the last two, these are the bad results that we wanted to not see. And look, we are not seeing them. So overall, this is an excellent, we really did not expect to see results this good. So I'm very happy with that. Okay, next slide, please. These are the same results for the display, and we more or less see the same thing. We do see in those first two sets that people churn a lot more for displays. They change their settings back and forth. But again, we see that the experimental people are more likely to change their settings during the experimental period than the control people are. We can't look at no sleep to sleep because practically everybody had sleep enabled, but we do see in that fourth set that for the people who already had display sleep enabled, the experimental group was much more likely to improve their settings and reduce the amount of time it took for their display to go to sleep. And again, in those last two, we do not see any sort of negative effects. So overall, it looks like the PMUI is really making exactly the kind of difference that we expected to. Next slide, please. These are some self-reports about how people liked the PMUI program. So this is only for the experimental so that we can compare. The first two are looking at how friendly you think the standard sleep settings are versus how friendly you think the PMUI program is. And it's 5.4 versus 5.0, which doesn't seem like a huge effect, but it is statistically significant. So we'll take that. And then there's a direct comparison of PMUI to standard on a 1 to 5 scale, and we're getting 4.1. So that's, again, a very good result. The bottom two are two scales. So these are a whole bunch of multiple questions that we look at an average for. The first one there, the usability of the app, is a standard usability scale, and we're seeing a very positive result on that, 4 out of 5 on average. And then finally, a list of the different features that they might have used and which features they found to be particularly useful. And again, we're getting higher than 3 out of 4, so that's, again, a very positive result. So overall, they seem to like the program. Next slide, please. So the rest of stage 3 is that we're looking to finish processing the results. We have a little bit of a preview that I just showed you here, but we have a lot more questions about how exactly did the feedback change user behavior and the patterns of user behavior. We haven't even started to be able to look at the energy savings, the actual energy monitoring that we were able to do, and exactly how much energy is being used in the various states and how much is being saved by the interface. We're also going to do a lot more work on the feedback on the interface, both in terms of what people were using, which we have recorded, and also what they seem to like better, and any sort of possible improvements that we could do to the program. And then finally, this is an incredibly rich data set in terms of what we now know about how users are behaving toward the power management features that we hope will be applicable to a wide range of other kind of power management questions. So finally, I had this as planned, but really this is hoped, because this isn't actually part of our current grant and we need more money for this. So if you like the sound of this, let me know. Stage 4 is we need to revise and distribute. So obviously the software is working, but we need to update it based on the little problems that we found. We need to create a standalone version that's a non-research version. Right now, the only version we have is going to keep giving us data about you. And then we want to find partners to help us to distribute and further develop this. So we're looking here at, again, a broad range of utilities, commercial, universities, businesses. Our whole idea here is that, we got public funding to do this. We want to make this as publicly available as possible, but we do need some help in terms of, we need to manage the software, run updates, run upgrades, et cetera. And then finally, we are also hoping to seek funding to help develop and test versions for laptops. The development shouldn't be that hard, but the testing is going to be a little tricky. So next slide, please. That's it. Thank you very much, and I'm looking forward to answering any questions you have. I can talk about computer power management all night.
Wonderful. Thank you so much, Michael and Joy, for your presentations. Gosh, there is a whole lot of work that you guys are doing over at CalPlug that's incredibly interesting. And if anybody in the listening in, the attendees have a question, please type your question in the question box and we will respond to that. I might start off with a question, Joy, about the PMUI system. And I'm curious if the dashboard itself automatically pops up on the computer screen or if this is something that you have to actively access.
It's a very good question. So both will happen. So you can open up the program anytime you want to and look at it, but we were especially worried about this issue that you bring up. Do we have to activate it? Because people will put it on their computers and then forget about it is the concern. So there's a weekly pop-up that pops up on Monday mornings and says, hey, would you like to look at your weekly usage report? And you can go straight to the program or you can dismiss it, but it does keep reminding you that this program exists and it will give you your usage report. We're hoping for the next version to make this a dynamic response where it keeps popping up to show you your usage report if you're not doing very well, but if you are doing very well, it kind of gives you a break for a few weeks and doesn't keep bothering you, because we're trying to find that good balance between putting it in people's faces so that they're going to be engaged with it versus not really annoying them.
Great, thank you. Yeah, that is an interesting topic. And I feel like sometimes you need those pop-ups or push notifications to keep that reminder going with these programs.
Exactly.
Yeah. One other quick question that I had too is I really liked that you were showing the pro-environmental messages for how much you were actually saving and what that equated to. We were wondering if you had thought about showing it in a cost format for how much cost savings they were saving with that.
In terms of the individual person cost savings, we have a real limitation there, because if we're going to make this a standalone program, what that means is that we have no idea what utility this person is using. We don't know how much they've used so far. We don't know what their current plan is. So it's actually very difficult for us to make an estimate for that particular person, how much energy they're going to save. So the estimates that we're using for the environmental feedback, those are pretty broad and vague, so we can kind of get away with having a margin of error there. If we're going to be trying to estimate how much they personally are saving, they can check that, and if we're wrong, then that might actually be worse to give them a wrong answer than to give them no answer on that at all.
That's very true. Some of the incentive programs that we've seen where companies are providing incentives to either tenants or individual employees for meeting energy targets for plug loads, et cetera, do involve some sort of financial gain. For instance, GSA with their tenants in one of their buildings, the Wayne Aspinall Federal Courthouse building. It's in Grand Junction, Colorado. It's a net zero energy building, and if they meet their target or come in below for their plug load energy, then they get a percentage of their rentable square footage fee back. So that's where this financial question comes into play too, and if we could use some of this data to infer, or the individual tenants could apply some sort of cost value to it, then that might help them to realize whether their tenants or individual occupants are actually meeting those targets moving forward.
Yeah, I think that's a great idea. Yeah. I was going to say, I think that's a great idea, but the concern that we have is that, again, we don't really know how much the person is paying for electricity, and we don't know how much that particular computer uses in idle mode, because we're finding that the computers really differ from one to the other. But yeah, we could certainly have estimates, which would be very useful, I think, in a macro sense. Okay.
Wonderful. Thank you. Marta, do you want to jump into other questions that have come on the line?
Yes, I would love to. We have a couple of questions in the queue, and I'll go down the line on these. This first one is regarding to CalPlug and your work with Tier 2 advanced power strips. I believe, Michael, you spoke to that a little bit early on when introducing CalPlug. And so this question is specifically regarding that. and it is this. What type of residential or commercial Tier 2 APS, advanced power strip projects, has CalPlug worked on with utilities? Are there any results published that you can share?
Yes, there are. So we've been involved back since 2014, setting up the initial field trials in California that were put together with San Diego Gas and Electric. The second part of that field trial was sponsored by Pacific Gas and Electric, but happened in the San Diego area. Both of those are reports that were published by an energy firm, AESC, and distributed through the manufacturers. You can find them on a web search, so they're available out there. In addition, we did a review of protocols used during field trials and presented this at a conference this summer, the EDAL conference. So this is available as a CalPlug paper as well. So there's 3 different ones on this. The area so far we focused on is residential AV applications.
All right,
Michael, are those located on your website too, those resources?
The two, actually, I believe through our Tier 2 APS portal. So tier2aps.calit2.uci.edu is the Tier 2 qualified product list we put together as a collaborative project with Pacific Gas and Electric. They are shown on that particular site. So again, that's tier2aps.calit2.uci.edu.
Great, thank you.
Wonderful. And if folks are interested, we can send that out after the webinar when we send along the slides and the link to the recording, just so everyone knows.
Perfect.
We have another question on the list. This one's back onto the PMUI project, and this is just kind of regarding barriers and potentially understanding the users of this project. And so the question is, based on the PMUI project, do you think that one potential barrier is that people don't understand the difference between idle and sleep? To what extent do you think this understanding plays a role?
That's actually a very good point. I think they don't really understand what sleep mode means, but I think the larger problem that we're running into is that they can't tell the difference between the monitor going to sleep and the computer going to sleep. So, sorry, we just had a fire alarm over here, so you won't. I'm going to have to do the question later. Bye. Oh. Sorry, I'm going to have to sign off here for a minute.
No worries. Thank you, guys. We're almost at the top of the hour anyways, so we'll wrap this up. We really appreciate it, Michael and Joy, for your time today. Sorry you are in the middle of a fire drill. You should go exit the building immediately.
We are going to go exit the building immediately. Thank you so much. Bye-bye.
Okay. Thank you. Bye.
Thank you, everyone.
Great. Fire alarms. Hopefully it's just a fire alarm for those guys, but we have to follow the rules. Okay, great. Holt, can you please skip to the last or the next slide here? If there are any additional questions for Michael and Joy, please email us. Our contacts are on these slides, myself, Kim, Marta, or Sarah May, and we will put you in touch with Michael or Joy to get responses to your questions as soon as possible. And with that, if there are any additional questions, comments, or member updates that anybody has and would like to share, please type that into the question box, or you can email us at the end of this call. Next slide. And with that, I thank you all for joining today. I hope you found this information useful, and we will keep you posted on when our next team call will be, which will be scheduled in about August or September of this calendar year. And thank you again to our technical presenters here, Michael and Joy, for their contribution and for teaching us about CalPlug services and what they do. And looking forward to meeting with you guys all soon. Thank you so much. Take care. Bye.
Thanks, everyone. Bye.